everyone, have you ever looked at a plastic bottle and thought, hey, this could be clean my room? Probably not, but we did it. For this Physics Apex project, we challenged ourselves to build a working vacuum cleaner using only simple everyday materials. Today, we will show you how we turn basic items into a budget-friendly cleaning tool. But before it, let's meet the team. Hi, I'm Cixin.
Hi, I'm Elaine.
Hello, I am User.
Hi, I'm Kazim.
Today's presentation will focus on introduction and objective, methodology, expected outcome and discussion, and finally conclusion. Let's start. A vacuum cleaner is a machine that uses suctions to remove dust from the surface. Most of them are powered by electricity and they come in many types. Please be alert, let's talk about physics. Our vacuum cleaner isn't just about spinning fans and noise. It's actually powered by some physics principles that you probably know but never realize applying to your living. First up, air pressure. Pressure is the force divided by area. The motor reduces air pressure inside the vacuum, and because natural has imbalance, outside air will rush into to fill the low pressure space, carrying all the dust with it. Next, Bernoulli's principle. Here's the idea. The faster air moves, the lower its pressure. So, when the motor speeds up the airflow, and bang, pressure drops inside the cleaner. This pressure difference sucks in air from the outside. And of course, we can't forget the conservation of energy. Energy doesn't just disappear, it changes forms. Electrical energy from the motor transfers into kinetic energy in the moving air, and that kinetic energy does the job of cleaning your room. So how does our homemade vacuum use this idea? As I mentioned, the motor inside moves air quickly, causing low pressure. The air outside, which has higher pressure, pushes dust and dirt into the vacuum. The dust gets caught in a dark bag. Alright, before we show you our awesome DIY vacuum cleaner, let's talk about why we even made this thing in the first place. Imagine this. You are a student, your room is a mess, and you definitely can't afford those fancy high-tech vacuums that cost more than your entire allowance for the years. So, objective 1, create a low-cost vacuum cleaner. We wanted to make something useful using affordable stuff because this helps reduce costs and even waste. Now for objective 2, to show how suctions and air pressure actually work. Let's be real, physics is way more fun when you can see it in action. We wanted to show you that with the right design, even a simple setup can create the same vacuum effect that a real machine uses. And finally, explore how small vacuums can be useful. Our vacuum cleaner, even small, that can clean your table, your keyboards, and that corner behind your bed you haven't touched in months.
To bring our mini vacuum cleaner to life, we gather a bunch of everyday items. Nothing too fancy. Here's what we use. A plastic bottle as main body, sellotape and double tape for strong sticking, one large wood block and one smaller wood block, two 1.55 volts batteries for power supply, a fan blade to create suctions, scissors to cut the bottle, battery holder to connect the batteries, wooden ice cream stick, screw and screwdriver, plastic pipe clip to hold the motor, fine mesh which acts as a dust filter, and finally a rubber band. Alright, now let's walk you through how we actually built our homemade vacuum cleaner. First, a 0.5 liter plastic bottle was cut in half to serve as the main body and dust collector. Then, a fine mesh was fixed to the open end of the bottle using a rubber band and secured with sellotape to act as a filter. Next, a double-sided tape was attached to the top of a wooden ice cream stick to form the base. After that, a 9x3x0.7 cm wooden block with a 0.3 cm hose was attached to the stick. Then the wooden block and a plastic pipe clip were fixed together using a screw to form the motor holder. The DC motor was placed between the clip and secured firmly. A fan blade was then attached to the tip of the motor. Next, the wires from the battery holder were connected to the motor and the holder was fixed to the wooden block. Finally, the bottle was attached to the opposite end of the stick, aligned with the fan, and two AA batteries were inserted to power the motor. Our mini vacuum cleaner was ready to go.
Let's talk about the real deal, how our homemade vacuum cleaner actually performed and what we learned from it. First, the challenges. One of the main limitations of our homemade vacuum cleaner was its quicker suction power. Since it was powered by a low voltage DC motor, it could only hover lightweight materials such as tissue paper or dust. Because of that, our first idea, testing with different distances, didn't work well. The vacuum could only stack things up when they were super close. So, we switched the variable to paper size instead. And here's our result. When the size of tissue paper crumbles increased, the time taken by vacuum cleaner to hover 10 pieces of tissue paper crumbles becomes shorter. The materials used, such as plastic bottles and wooden sticks, while cost-effective and eco-friendly, were also less durable, which means the vacuum cleaner had to be handled carefully. But here comes the good news. It's lightweight and easy to carry. You can take it anywhere. And it is perfect for tiny places. And best of all, it is eco-friendly and made of stuff you probably already have at home.
In conclusion, we did it. Our goal was to create a cost-effective, eco-friendly vacuum cleaner, and we successfully achieved this. We took basic items like a plastic bottle, fan blades, and a small motor and turned them into a working machine that uses real physics such as air pressure, Bernoulli's principle, and conservation of energy. Our experiments show how the size of objects affects suction time. The smaller pieces get picked up faster, and the larger ones take the more effort. More importantly, this project shows the value of sustainability, creativity, and applying science in real life. That's all from us. Our homemade vacuum cleaner may be simple, but it shows how basic materials and physics can create a useful tool. Thank you.